So what we can do is we can start with electrochemistry. There was there's the AQA part. So you get electrode potentials and electrochemical cells. Do you know what electrode potentials are? Have you ever heard of them?
No, I haven't.
Okay. So we did a bit of electrochemistry in AS, but that's very basic. That's like more like O-level stuff. Where we did just hold on a second. Where we did redox reactions mostly. So we're gonna just try and revise some of those redox reactions initially. So starting with how do you define reduction?
Is it the gaining of electrons?
Okay, so that's a gain of electrons. When something gains electrons, its oxidation state decreases, right? And it's also known as gaining of hydrogen atoms, not ions, but yeah, like entire atoms. And it's also known as loss of oxygen atom. And your oxidation is the reverse. It's the loss of electrons. The oxidation state decreases. So it increases. And so it's also known as the loss of H atoms. Or the gain of oxygen atoms. Okay, and if I have so if I have a number line, this is 0, this is so if I go in the upper direction, then that's oxidation. Vice versa, if I go in the downward direction, that's reduction. So quickly tell me what's this if I go from Cl-7 to Cl-1? What happened? Oxidation or reduction?
Oxidation.
Okay, so that's a loss of how many electrons?
6.
Because that's similarly if you have Al3 plus and it turns into Al1 plus.
Reduction.
Okay, that's a gain of 2 electrons, right? So basic stuff. So then you had something called the oxidation state. So that was basically the charge on the element, but it's not exactly the charge when it comes to when it comes to oxidation and reduction. We don't really care whether the electron is gained completely or whether it's gained slightly. We just care who's gaining the electrons. That's it. So this is the charge on the element, if the compound were ionic. So I've got ionic compounds where one element is very electronegative. So when one element is very electronegative, like in this case, Cl is the one that's very electronegative, then it literally gains electrons, and Na literally, in reality, it actually does lose electrons. So Na is the one that's +1 and Cl is the one that's -1. So that's what happens in ionic, but you don't have all compounds are not ionic. You've got compounds that are polar covalent. So like HCl, now HCl, Cl is more electronegative, but its electronegativity difference is not very high. So Cl gains the electrons, but it gains the electrons slightly. H loses the electrons, but it loses the electrons very slightly. Now, let's just, I said now, but when it comes to redox, we don't really care who's gaining or who's losing the electron slightly. We just care who's got the electron. So this is +1 and this is -1. Is that clear?
Yep, it's clear.
And then you have the last one where maybe you have a compound that's completely ionic. So you're completely covalent, perfectly covalent, non-polar. So no one ends up gaining or losing electrons. So they both have an oxidation state of 0. So no one gains or loses electrons. So you can apply the same idea to many different elements or compounds. So for example, if I have oxygen with water, so the electrons over here in who's going to gain electrons? Who's more electronegative?
The oxygen.
So oxygen is the one that's more electronegative. So oxygen is the one that's going to be -2, although it slightly gains electrons. And hydrogen is the one that's actually +1 in this case. If I have oxygen with fluorine, now where would the electrons be closer to?
The fluorine.
Fluorine is the most electronegative element, right?
Yeah.
So in this case, oxygen is going to be +2, and fluorine is the one that's gaining electrons, so that's -1, right? So although it's not completely gaining electrons, but you're going to treat it as if it's ionic, right? And you can, as इसका बता दो कि you've got so these electrons, who's going to gain those electrons?
The oxygen.
These electrons are gained by oxygen. This one over here. What about the electrons that are in the middle?
They don't move.
No one gains them, right?
Yeah.
So oxygen only gains 1 electron. This oxygen also gains 1 electron. Hydrogen is +1 and this is +1. Okay, so the idea is that you can figure out oxidation states if you know the electronegativity of a substance. For example, you can you can apply the same concept. I mean, this is rarely going to be used, but sometimes this helps. Can you figure out how many electrons are gained and lost by the carbon in the middle?
Is carbon more electronegative or hydrogen?
It is.
Okay. So does it gain 2, but then it loses 1?
No, it loses.
Or 2, loses 2.
So it loses 2, but it also at the same time. So carbon is going to be exactly what, I think it's going to be exactly 0, right? This is going to be +1. This is going to be +1 as well. This is going to be -1. And the one that's in the middle, so the one in the middle is going to be exactly 0, right? Okay, so that's going to be exactly 0. But anyways, that's like a crude way. I mean, that's like the actual way of finding oxidation states. Okay, so, but then you're going to use a shortcut, which is what that you'll just refer to a table, which is that neutral elements, the oxidation state is exactly 0. When it comes to compounds, when it comes to compounds, uh, group 1 is +1. Group 2 is +2. Group 3 is +3. Transition metals have variable oxidation states. Oxygen is usually -1, so -2, but with exceptions. Oxygen is the most electronegative element, so we are pretty sure that it gains electrons from everyone. Except we did some exceptions like H2O2, where it's actually -1. And with F. Because F is the only one that's more electronegative than oxygen. And then you've got hydrogen. Now, hydrogen is normally +1 because it's the least electronegative, one of the least electronegative non-metals. But when it comes to metals, then it's more electronegative. So except with metal hydrides. So for example, if you've got NH, then Na is the one that's going to lose electrons. H is the one that's going to gain electrons. Okay. So we're going to use these examples, and then we're going to try and find oxidation states. So for example, if I have H2SO4, how do I figure out the oxidation state of H2SO4? What I do is H is +1. Sulfur is unknown, so that's X. Oxygen is -2. And there are 4 oxygens. There are 2 hydrogens, and there's only 1 sulfur. I'm going to add all of them up to be equal to the total charge, which is 0. So, what's the value of X?
Is it 6?
So over here, it's going to be 6. So try and just do these now. What's the oxidation state of N? In N2O first, then HNO2, then in NO3 -1, then in NH4 NO3. First one, N2O, what's the oxidation state of N?
Um, Is it 1 plus?
Okay, so that's +1. What's the oxidation state of HNO2, N in HNO2?
Is it 3 plus?
Okay, so it's this one is +3. What about NO3 -1?
Is it 5 plus?
Okay, what about NH4 NO3?
For which element?
N.
Is it 1 plus?
So now remember to treat them as separate ions. This one is what? NH4 +1, while this one is NO3 -1. So the two ends are not basically equivalent. So don't think of them as the same, having the same oxidation state. Now for one end, you already found this out. This was +5, right? What's the other one?
-3.
To you, that's -3. So you know about oxidation states, right? So that's about oxidation states. What we need to do now is just practice the whole balancing redox stuff. So now balancing redox equations. The electrons gain and loss, they have to be made equal. Okay, so the electrons gained and the electrons lost, they have to be made equal. So let me just find out if I have a worksheet on this. Hold on 1 second. So now try electrons gain. Let's start with the simple one. Na reacting with Al3 plus. And on the other side, you're getting what? You're getting Na +1 and Al. So first thing, who's the oxidizing agent? Who's the reducing agent?
Is the sodium the reducing agent?
So sodium is the one that's getting so that's getting oxidized. So it's definitely the reducing agent and lost 1 electron, right? And Al is the one that gained electrons. So it got reduced. And it gained 3 electrons. Now so one got oxidized, the other one gained 3 electrons, and you've got so you just have to multiply Na with 3. so that the electrons gain and lost are equal. Okay, Varda, is this clear?
Yep, it's clear.
I said try balancing this in a similar way. You got SO3 minus 2. It reacts with ClO3 minus 1. And what you get is SO4 minus 2. And you get Cl minus 1. So pehle who gain electrons and how many electrons? Find this out.
Is the SO3 2 minus oxidized?
It goes from what?
Because the sulfur changes from 4 plus to 6 plus.
You plus 4 to plus 6, and that means it ends up gaining losing 2 electrons, right?
Yep.
What about Cl?
So the Cl is reduced because it goes from 5 plus to 1 minus.
So gain how many electrons?
6.
So I just need to multiply the sulfur with 3, right? And hopefully the oxygens are also balanced, right? Can you just confirm the oxygens are balanced, right? 9 plus 3, that's 12. I think that's balanced, right? So try doing the same thing for we've got SN2 plus. So who got oxidized?
The SN.
So the SN got oxidized. And so how many electrons lost? Lost 2 electrons, right?
Yeah.
And what happened to Mn?
It was reduced from 7 plus to 2 plus.
So it gains 5 electrons, right? So I need to multiply this by 5. And I need to multiply Mn by 2, so there's going to be 2 Mn's, right? And then I can balance the oxygens. There are 4 oxygens, there should be 4 H2Os, that's 8. So that's 8 hydrogens. So the things that are not involved in the redox, I can balance them, atomize later on, okay? Clear?
Yeah, that's clear.
So try and do these Let's try and do these questions 1 second. So I've got Cr plus ClO4 minus and OH ions. And then it's CrO2 minus and ClO3 minus plus H2O. इसको खुद ही try and balance this. टी इक्वेशन है ठीक है. अच्छा 7 is +7 +2, so that means कितने हो गए? That's 2 electrons lost. Hold on a second. अच्छा, that's so 5 electrons gained, right? What's carbon? Carbon is +4 over here in carbon dioxide. What's C2O4 -2? What's the oxidation state of carbon over here? In this,
I thought it was 3+.
yeah, I think that's +3 as well, right? So it is +3. अच्छा ठीक है, so I think you. अच्छा, so it means it gained what electrons? 1.
Yeah,
So he lost 1 electron, right?
yeah, lost 1 electron.
So now the thing is, I can't. That's for 1 carbon, right? You don't have 1 carbon. You actually have 2 carbons. So I would have to multiply this by 2, and I would have to multiply the. Sorry, I would have to like double everything. But I can't really multiply it by 5, right? Because the problem is I can't have 5 carbons, so I would have to go into fractions. Is that idea clear?
Not really.
I mean, but is this clear that I need to multiply this by 5, right?
Yeah, that's clear.
So I should have 5 carbons over here, right?
Yeah.
So I would not.
Oh, that makes sense. Okay.
Okay, so the trouble is with an odd number, it doesn't really work. So I would have to multiply it by 10. So that way I can have 5 over here, 10 on this side, and I can multiply this one by 2. So in that way, one second. So in that way, I can have do this, and we can just balance the oxygens. We got how many? 20 oxygens and 28 oxygens. So that's 20. So I think 8 over here. And then we can focus on the hydrogens, which is 16, I guess. ठीक है, clear?
Yeah, it's clear.
बस ठीक है. So do the last one and send it on WhatsApp then, ठीक है? Send me the answer solution on
Okay.
WhatsApp. चलो ठीक है, brother.
Okay.
Okay, take care.
Okay. Thank you.
Office.
Allah Hafiz.